Welcome to video 2.4, summarizing deviations from the mean. Long title, simple process, so let's get started. Vocabulary you need is first, what is a deviation? A deviation is the distance a data point is from the mean. This X with the line over it is the symbol for mean. So to calculate deviation, we're going to do that on the next page. To calculate deviation, you take your data point and subtract it from the mean. So let's say we had a data set and the mean of this data set was 20. And one of our data points was 18. To find this data, you do the deviation from the mean for each individual data set. For this data set, you would take 18 minus 20 and find out the deviation is -2. Simple as that. Variability is what we use to describe the spread of data. The spread of data is how far it's spread out. The range, maybe you can look at that. And the greater the variability, the greater the spread of data. So the greater your deviations are from the mean, the greater your spread of data is. If you have very little deviations from the mean, your data will be symmetrical, all clumped around the median and the mean. But if you have wide variability, it's going to look more like this, be all over the place, or be very skewed. So, like I said, variability is the way we describe data. It either has greater variability, like this one, or very small variability when there's not a lot of deviations from the mean. So to calculate deviations, remember this formula right here. You take your data point and you subtract the mean from it. So the first step in finding the deviation is to find the mean of the data set. And then you subtract the mean from each data point. We're going to work with this problem here. 5 high school students were asked how many hours per week they spend watching TV. Their responses are as follows: 6 hours, 4 hours, 6 hours, 7 hours, 8 hours. So 6 plus 4 plus 6 plus 7 plus 8 is 31. And then 31 divided by 1, 2, 3, 4, 5 is 6.2. So our mean of this data set is 6.2. So I'm going to take each of these data points and subtract 6.2 from them. So we have 6 minus 6.2, and that is -0.2. We have 4 minus 6.2, and that is -2.2. We have 6 minus 6.2, which we know is -0.2. We have 7 minus 6.2, which is 0.8. And then we have 8 minus 6.2, which is 1.8. So there we found the deviations from the mean. And look what you notice about our mean and about numbers that are lower than the mean and numbers that are higher than the mean. Numbers that are higher than the mean have a positive deviation, and numbers that are lower than the mean have a negative deviation. So make sure you get that down. So now we're going to look into comparing variability. So we have another set of data that we're going to compare to our old data set, which is right here. 5 college students, last time was high school students, 5 college students were asked how many hours per week they spend watching TV. Their responses are as follows. Okay, so we have a 2, a 3, a 7, a 6, and a 12. And that all equals 30. When I divide 30 by 5, I get 6. So the mean for this data set is 6. So I'm going to take 6 and subtract it from each of these 5 data points. So 2 minus 6 is -4, 3 minus 6 is -3, 7 minus 6 is 1, 6 minus 6 is 0, 12 minus 6 is 6. So if we notice, while they have very similar means of 6 and 6.2, these deviations are much greater than these deviations. These ones are all pretty close together. None of them are greater. Well, one is greater than 2 by very little. None of them really go over 2 or 2.5. These have a much bigger variety. So because of this bigger spread, and you can also look at the range is the difference between the smallest and the lowest and the highest data point. The range would be 10. And the range for the bottom one would only be 3. The range also plays into variability. The greater the spread of data, the greater the variability. So I'm going to say that the college students have the greater variability because if you look at their deviations, they're much more scattered than these deviations. And if we were to plot this data, it would not be a consistent data set. This one would be much more symmetrical, and this one would be much more skewed. So take that into account as well, that skewed data sets usually have the greater variability as well. So your hot question for this video, the scores for 8 math quizzes are below. What is the deviation from the mean for the student who scored an 87? So I want you to calculate the mean, then find the deviation from the mean for the student who scored an 87. Answer that in your hot question. I will see you on Monday.